Hello, in this video we're going to learn about solving simultaneous equations using multiple methods. To start with, we define simultaneous equations. So simultaneous equations are a set of equations with multiple variables that are being solved together. So for example, on the left here we have two equations of two parameters x and y, and we'd like to solve for the value of x and y that satisfy these two equations. On the right, we have three equations and three unknowns, x, y, and z, and we'd like to find the values of x, y, and z that simultaneously satisfy those three equations. In our circuit class, those variables x, y, and z can be the current and voltage at different branches and nodes respectively, and we'd like to find the values of the current and voltage that satisfy some certain constraint using KCLs, KVLs, and node and loop analyses. Okay, so to reiterate, our goal is to find the solution where all equations in the system are simultaneously satisfied. In order to do so, we have four popular methods to solve simultaneous equation. One is substitution method. The second one is elimination method. The third one is the graphical method. We are going to cover these three methods in this video. And the fourth one is the matrix method, and we're going to cover it over the next two videos. So let's start with the method of substitution. With the method of substitution, let's assume that we have two equations like these. What we're going to do is we're going to use one of the two equations to solve for one variable as the function of the other variable. So here I can solve for x as a function of y. So I can write that x is equal to 4 minus y over 2. Once I have this expression for x, I'm going to substitute it into the second equation. Okay, so in the second equation, I have x, so 4 minus y over 2. So this is x, and then minus y, so this, what we have here is x, equal to negative 1. So now the second equation, after substituting what we have for x, is now one equation in one variable, which is y. We can solve for y. Once I have a solution for y, I can substitute y back here into that expression for x, and this complete my solution. So let's see the steps here. So I have the two equations. I'm going to solve or express one variable in terms of the other using one of the two equations. So here we use equation number 1 to solve for x as a function of y. Once I have this expression for x, I'm going to substitute that x expression into equation number 2. So in equation number 2, I have x here. I'm going to substitute that x via the expressions that we have from equation number 1. Now, this is one equation in one unknown, y. I can algebraically modify it and solve for y. Once I have this final solution for y, I can use this expression or either of the two equations to solve for x, since the value of y now is known. So use any equation, substitute y here is equal to 2. This is the solutions that we obtain for y. We can immediately solve for x. So this method is called substitution method. The second method that we have is the method of elimination. With the method of elimination, we look at our equations and we see how we can algebraically add them or subtract them so that I can get rid of some of the variables. So for example, in this example here, if I add equation 1 to equation 2, you can see that I'm going to get rid of y. And then I'm going to end up having one equation and one unknown, which is x. I can solve for x. And once I have a value for x, I can use either of the two equations to solve for y. So let's see this example in more details. So here I have equation 1, equation 2. Algebraically multiply by any constant and then add or subtract so that you can get rid of one of the two variables. So here I don't need to multiply by anything because addition directly will get rid of y. So the equations that I have would be 3x equal to 3. This will give me a solution for 1, for x. Once I have the solution of x, I can substitute in any of the two equations to solve for y. So here we choose equation number 1, substitute x by its solution, which is 1. Now we have only one equation in y, which we can give us y equal to 2. And note that this is the same solution that we obtained in the, the method of substitution. Those methods are different ways to solve the system of equation, but the solution would be the same no matter which approach you use. The third approach that we have is the graphical method. But this graphical method would be convenient if and only if we have two variables, like for example here x and y. But if we have x, y, and z, we will need to plot a three-dimensional figure, which might not be convenient, and the previous two methods are more convenient than the graphical method. So if you have two equations and two unknowns, what I'm gonna do is these two equations are linear equations, so they can be plotted as a line equation into the xy space, or variable 1 and variable 2. Okay, and again this xy can be here, this is the current and element number 1, this is maybe the voltage at node number 1 in our circuit analogy. Okay, but here for generality let's just keep them as two variables x and y. So all what I need to do is plot a line, and as you know, to plot a line I need 2 points on that line. Each equation corresponds to a line, and we are looking for the solution xy that satisfies the two equations. So the solution would be the point of intersection on the two lines. So for example, the two equations that we have throughout this video, here I can represent this line as y equal to 4 minus 2x, and I can plot this line using two values for x. I can get the corresponding value of y and generate a line. Likewise, here we can write that y is equal to x plus 1. So this is another line equation. The solution, so here I have the two lines. The solution is the point of intersection, because this point of intersection is the point that satisfies the two lines, i.e. the solution that satisfies the two equations. So this would be our solution. You can see here the value of x is equal to 1 and the value of y is equal to 2. So this is our solution. X is equal to 1 and y is equal to 2. So these are the three methods that we can use for solving simultaneous equation. The fourth method is by constructing a matrix form, and this is what we're going to learn in the next video. Thank you.